Hey everyone, myself Rohit. I am from IT Guwahati, pursuing BTech first year in Computer Science department. So today I and my group mates are gonna discuss few assignment questions. So straight away let's dive into the first question. Here we go. You are analyzing an embedded control system that uses 8-bit 2's complement arithmetic. The system receives three sensor readings X, Y, and Z. The respective values are given. Our task is to represent these values in the processor's 2's complement binary format and determine which arithmetic operations will exceed the system's representable range. So x plus y plus z, and x plus z. So, okay, let me give a quick brief about 2's complement arithmetic. Most modern computer systems represent signed integers using 2's complement notation. Positive number is same as normal binary representation. And while representing the negative number, first we take the positive number and then follow the two subsequent steps in order to represent in the negative number. So first of all, we take the positive number, represent it in the binary representation, and then invert the bits and then add one. So following these subsequent steps, we get the representation of the negative number. And then in n-bit system, the range of numbers that can be represented in 2's complement form is from minus 2 power n minus 1 to 2 power n minus 1 minus 1. This is the range of numbers which we can represent using an n-bit system, right? So moving forward, overflow occurs during arithmetic operations if the result is out of range and if sum of two same sign number gives a result of opposite sign. It means that, for example, we are adding minus 127 and minus 120, let us suppose. It gives minus 247, right? It's like 8-bit notation system. In 8 bits, like the smallest negative number that we can represent, one is 128, right? Minus 2 power n minus 1, minus 2 power 7, which is 128, minus 120. But then the result of the addition arithmetic operation that we are performing is minus 254. It's exceeding the range. Such an arithmetic operations result in an overflow. Overflow means typically we are unable to represent the result in the bit representation system. And how to determine whether an overflow occurs or not? You can use two methods. 2's complement has an unfair advantage compared to the 1's complement and then the sign magnitude form. That is, we can just check whether if carry in Cn is equal to carry out, then overflow will not occur. If carry in is not equal to carry out, then overflow will occur. Feature is not available in the past few two forms that we have discussed. If during the arithmetic operation of n bits, if we get a result of n plus 1 bits, then leftmost bit, most significant bit, must be discarded. This is the rule. All right. So the other thing which we use to determine whether an overflow occurs or not, like for example, when we are adding two positive numbers, then the resulting representation, if we get it to be a negative number, then we say that an overflow occurs. But then this is quite difficult to calculate every time, right? So that's why the most computer systems nowadays use 2's complement arithmetic. Coming to the question, given 8-bit system, the range of numbers that can be expressed is minus 128 to 127. X is given to be as minus 35. So the first step is take the positive, like take the modulus value of it. The modulus value is 35 and it can be represented as 32 plus 2 plus 1, which gives us the binary representation of it 0, 0, 1, 0, 0, 0, 1, 1. And then the next step is to invert the bits, which is 1, 1, 0, 1, 1, 1, 0, 0. And then add 1 to the least significant bit. So adding it 0 plus 1, 1, performing the whole arithmetic operation, we get the result to be 1, 1, 0, 1, 1, 1, 0, 1. So we have got the representation of x in the 2's complement form. Moving forward to y is given to be as minus 110. Taking the modulus of it, it is 110, which can be represented as 64 plus 32 plus 8 plus 4 plus 2, and then representing it in the binary representation, inverting the bits, and then adding 1. So here comes some interesting part. When we add 1, 1, the result is like 1, 0. So 1 will be carried forward. So 1 will be carried forward to the next one. And then again, the same arithmetic operation, which we typically do. Yeah. So we have managed to find out the value of y. So let's in the same procedure. Let's find out the value of z as well. Z minus 50, taking the modulus, representing it in the binary format, inverting the bits, adding 1, performing the addition carefully, we get the z value to be 11001110. So yeah, now we need to add them, right? From here, my group mate, Siddharth Misro, will be taking over. Thank you.
Hey everyone, I am Siddharth Misro. I am a student of first year in the Department of Computer Science at IITG. Today, I am going to discuss a question where we have to find whether the arithmetic operation gives an overflow or not. So straight away, let's do the question. As you have already seen, my friend Rohit Datta has given a brief introduction about the overflow cases and also the arithmetic rules. So I want to emphasize the point that the main condition to check whether the operation gives an overflow or not is checking whether the carry in and carry out terms are equal or not equal. The carry in term is like the carry that comes into the MSB, and carry out is like the carry that comes out of the MSB. So if these two are equal, carry in and carry out are equal, then the arithmetic operation will not lead to an overflow. If they're not equal, it will lead to an overflow. So with these rules, we can do the question. Uh, so we have the x plus y leads to an overflow or not. So x is equal to minus 35 and y is equal to minus 110. The value of x is 11101101, which is found by our friend Rohit Datta, and y is also found out by him. So it is 100101010. The addition is very simple, like 1 plus 0 is 1. It can be rather more precisely as 0, 1, and 0 plus 0 is 0, 0. 1 plus 1 is 1, 1, 0. So, and also 1 plus 1 plus 1 is double 1. Okay. With these four things, we can move forward. So you can do the simple operations, and the main focus is on carry in and carry out. So carry in is coming as here we can see the bit which is next right to the MSB is 1 plus 0, which is 1. So 0, 1. 0 goes into the MSB as carry, and 1 remains in the bit right to the MSB. So carry in is equal to 0. And if we come to the part of carry out, it will be carry is 0 plus 1 plus 1, that is 1. So carry out is equal to 1. And so here carry in and carry out are not equal. Carry in is 0 and carry out is equal to 1. So it leads an overflow. So you can also check it by finding the decimal value of this x plus y decimal binary value. So it will come out of the range of the 8-bit 2's complement form. You can do also this way, but it is too long. I won't suggest it. Next, if we see y plus z, y is y minus 110, which can be written in 2's complement form as 100, 100, 10, and z is 11, 00, 1110. So by adding them, main focus on carry in and carry out. So carry in, here the bit right to the MSB is 0 plus 1. 1 remains here and 0 goes to the MSB as carry. So carry in is equal to 0, and carry out is like 0 plus 1 plus 1, that is 1, 0. So 0 remains here and carry out is equal to 1. So carry in not equal to carry out. So it is also an overflow. Here we can see that if we find the y plus z decimal value, it will come as a positive number, but y and z are respectively negative numbers. The sum of two negative numbers cannot be positive, so it is definitely an overflow, but this method is not suggestible. Okay. So next, x plus z, x is minus 35 and y is equal to minus 30, minus 80. I'm sorry. Okay, x is equal to 11101101 and z is equal to 11000011. So by adding them, let's mainly focus on carry in and carry out. So the bit next to right to the MSB. So it is 1 plus 1, that is 1, 0. 0 remains here and 1 goes as carry. So carry in is equal to 1. And again, I have already said 1 plus 1 plus 1 is 1, 1. So 1 remains in the MSB and carry out goes as 1. So carry in is equal to 1 and carry out is also equal to 1. So carry in is equal to carry out here. So we can say in this case, it does not lead to an overflow because carry in and carry out are equal. So x plus y is an overflow, y plus z is also an overflow, but x plus z does not lead to an overflow. This is the answer of the question. I hope you understood it. Thank you. From this point, my friend Pranit Saibarat will continue. Okay.
Hello everyone, my name is Pranit Saibarat. I am from IIT Guwahati, studying computer science engineering in first year. I am going to discuss a question of our assignment. The first question has already been discussed by my friends, Rohit Datta and Siddharth Mishra. Without any delay, let's go to the second question. The given question is to show the leftmost derivation of the string, rightmost derivation of the string, and to draw the path for the string BB, which is a palindrome. It is emphasized about leftmost derivation. Leftmost derivation is obtained by replacing the leftmost variable in each step of the derivation. Similarly, the rightmost derivation is also obtained by replacing the rightmost variable in each step of the derivation. What is the use of these derivations? They give the basic idea for the construction of the parse tree. Now let's see the leftmost derivation of the given string. We are given the string S, which can be divided into BSB or ASA or B or A. Let us first divide the string into BSB. In the further step, again divide the S into BSB. Now let us divide S again into ASA. Now further S can be divided into ASA. Now consider the final step, divide S into B. Now we get the final string BB, which is our target string. Now let us go to rightmost derivation. Now divide S into BSB. Further in the next step also divide S into BSB. Now change S into ASA. Continue S to change as ASA. Now getting to the final step, change S into B, and the final string we obtained is BB, AA, BB. This is our target string. Parse tree. What is parse tree? Parse is obtained after syntax analysis. First, lexical analysis takes place. If there is no lexical error, then syntax analysis takes place, and parse is obtained from the syntax analysis. Parse tree starts with the root and ends with the leaf. What is root? It is the starting point of the parse tree. What is leaf? It is the ending point, which has no extensions, which has no children. It cannot be further divided into branches, and the parse tree contains branches. Hence, we can say that parse tree will be ended by leaves. Now, consider the parse tree of the given string S, BB, AA, BB. S can be divided into B, S, and B. Now, here B cannot be divided further. Hence, here B is considered the leaf, and S can be divided further. It can be divided again into B, S, B. In this step also, B cannot be divided further into anything. Hence, here B is a leaf. Now, S can be divided further into A, S, and A. In this step, A cannot be divided further. And so in this step, A is considered the leaf, and S can be divided further, and we can divide it into again A, S, and A. In this step also, A is a leaf, and it cannot be divided further into any extensions. Now finally, we can divide S into B. The parse tree will be same for the both derivatives. Now we obtain the final string by combining all the leaves. But by combining the leaves here, we get B, B, A, B, A, B, B. It is our final string and it's a target string. By this, we can construct the parse tree.